Okay, so today we are going to look at arguably one of the most famous theorems in calculus. So here we have limit as x approaches 0 of sine x over x. And the theorem is that this limit is equal to 1. So today we are going to prove this theorem, which we are going to prove by something called the Squeeze Theorem. Okay. So because this involves a little bit trigonometry, let's start off by drawing the unit circle. So let's just create a sector here. So suppose this angle is our x, okay? We can create two different triangles in this unit circle. First of all, we can create a smaller triangle here, which is inside the sector, and we can create a second larger triangle, which is outside the sector. So suppose we have the smaller triangle, so I'm going to write it right here. The smaller triangle. Let's say we give it a name A. We have the sector called S, and we have the larger triangle called B. And therefore, we can get an inequality, which is A is smaller than S, which is, smaller than or equal to S, which is smaller than or equal to B. So now we just need to get the area of the two triangles and the sector. So first of all, let's look at the smaller triangle. So we know that, already here, we know that the area of a triangle is equal to half of base times height. So we just have to really find base and height. So because this is in a unit circle, we know that this is 1 and this is 1 because these are basically the two radiuses in the unit circle. And in the context of this question, let's say we have a sine of x, in which x is the same x here. So what is sine of x? Sine of x, this is perpendicular to the radius. Okay, so sine of x in this context is actually equal to the opposite divide the hypotenuse, which is this side divided by this side. We know that this side is 1, so what this is telling us that basically sine of x is equal to the opposite. So let's label this opposite. And we realize that this opposite is actually the height we want to find. So now we have the height of the smaller triangle. What about the base? Well, see, the base is just the radius, so the base is actually 1. So A is actually just half of sine of x, because it is 1 over 2 times 1 times sine of x. This is basically our height, which we want to find. So now we want to find the area of the sector. So how can we do that? We just have to use one single formula, which I believe you guys are really familiar of, which sector, the area of sector is equal to 1 over 2 radius squared times theta. And so in the context of this question, radius is equal to 1 and our theta is equal to x. So the area of our sector is equal to x over 2. So let's just write it here, x over 2. Now finally, we want to find the area of the bigger triangle. Now again, we already have the base. Now we just need this height here. So how can we find the height? Again, we can write out tangent x. And in the context of our unit circle, we know that this is equal to the opposite divided by the adjacent. So O divided by A. Now we know that adjacent is 1. So basically, this tangent is equal to our opposite, which is our height, which is basically what we want to find. So this is actually just over 1, which is O, which is the height we want to find. So now we have both the base and the height. So the area of B is, again, 1/2 tangent of x, because again, it's 1/2 times our base, which is 1, times our height, which is tangent, which we just proved. Now we get a complete inequality here. Let's just simplify it down a bit. So let's just cancel out all the 1/2's, which leads us to sine of x smaller or equal to x, which is smaller or equal to tangent x. Okay, now we can write tangent x as sine of x over cosine of x. Now divided by every side with sine of x, this is what we're going to get. So this divided by sine of x is obviously 1. Middle, x divided by sine of x is x over sine of x. Now finally, the right hand side, we get 1 over cosine of x. So just to make it clear, we divided by sine of x. Okay. So now let's substitute in our x equals 0. X equals 0 from our limit. Okay. So what this leads us to is 1 strictly smaller or equal to x over sine of x, which is smaller and equal to 1 over, so what is cosine 0? Cosine 0 is 1. So it's smaller equal to 1 over 1, which is 1. So we have here 1 smaller equal to x over sine of x, smaller or equal to 1. So what this inequality implies is that x over sine of x is equal to 1. This is the concept of the Squeeze theorem. And if we just change it slightly, if we just switch the numerator and denominators, we get the opposite, basically, conjugate. The answer is still 1. And therefore, we prove our theorem that limit as x approaches 0 of sine of x over x is equal to 1. Well, obviously, we don't consider this method as the fastest. If you are familiar with the L'Hopital's rule, you can basically solve this in like less than in several seconds. So I'm just gonna write method 2 here. Method 2, which is called the L'Hopital's rule. So what we're doing is that because we get, so if we use direct substitution, substituting x equals 0 into this equation, what we get is 0 on the top because sine of 0 is 0 over x 0, so 0 we get in indeterminate form. So what we do next is taking the derivatives on both the numerator and denominator. So what we get is limit as x approaches 0, sine of x is equal to limit as x approaches 0 of, so taking the derivative sine of x is cosine of x, and the derivative of x is 1. And substituting x equals 0 into the equation, we get cosine 0 over 1, which is equal to 1. This method is much faster, but I think we'll cover this later after we complete our session about derivatives and all that stuff. So I hope after this video you'll have a better understanding of this famous theorem in calculus. And I guess this is all for today.